Every second of your life, trillions of tiny invisible particles called neutrinos are passing through your body. They move through your skin, bones, organs, and even the entire earth beneath your feet. You do not feel them, see them, or notice them in any way. They go straight through you as if you were not even there. It may sound like science fiction, but it is completely true. Neutrinos are real particles that scientists have studied for many years, and they are one of the strangest and most mysterious things in the universe. Neutrinos are what scientists call subatomic particles, meaning they are smaller than atoms. Everything you can see and touch, the air, your body, water, rocks, and stars, is made of atoms. Atoms themselves are made of even smaller parts: protons, neutrons, and electrons. But neutrinos are smaller than all of these. They belong to a family of particles called leptons, which also includes the electron. The big difference between electrons and neutrinos is that electrons have an electric charge, while neutrinos do not. Because neutrinos have no charge, they do not feel the pull or push of electricity or magnetism. This is one of the reasons they can move through matter so easily. Another special thing about neutrinos is that they have almost no mass. For a long time, scientists thought neutrinos had no mass at all. But later experiments showed they do have a very tiny amount. So tiny that it is difficult to measure. In fact, a neutrino is at least 1,000,000 times lighter than an electron. Because they are so light, neutrinos travel extremely fast, almost at the speed of light. They are like little ghosts flying through space and matter without stopping or slowing down. You might wonder where all these neutrinos come from. The biggest source of neutrinos that reach Earth is our own Sun. Inside the Sun, nuclear reactions are constantly happening. These reactions change hydrogen atoms into helium and release huge amounts of energy. Along with that energy, the reactions produce enormous numbers of neutrinos. Every second, the Sun sends out about 10,000 billion neutrinos in all directions. By the time they reach Earth, around 65 billion neutrinos pass through every square centimeter of your body every second. That means, while you are sitting or standing right now, hundreds of trillions of neutrinos are moving through you, completely unnoticed. The Sun is not the only place where neutrinos are made. They are created everywhere in the universe. Stars, for example, produce neutrinos during their normal life cycles, and when they explode in massive events called supernovae, they release even more. The explosion of a single large star can send out more neutrinos in a few seconds than the Sun produces in its entire lifetime. Some neutrinos also come from inside the Earth itself, created by radioactive materials in the planet's core. These are called geoneutrinos. In addition, when high-energy particles from outer space, known as cosmic rays, hit our atmosphere, they create showers of smaller particles, including neutrinos. Humans also produce neutrinos in nuclear reactors and in scientific experiments using particle accelerators. So, neutrinos are constantly being created both naturally and artificially. The reason neutrinos can pass through your body so easily is that they very rarely interact with matter. Most particles are stopped by other particles because they are affected by forces like electricity or magnetism. For example, when you touch a wall, the electrons in your hand push against the electrons in the wall, and that is why you cannot pass through it. Neutrinos, however, have no electric charge and barely any mass, so they do not feel those forces. The only force that affects them is the weak nuclear force, which is one of the 4 fundamental forces of nature. The weak force, as its name suggests, is extremely weak, so a neutrino almost never collides with anything. It can go through entire planets, stars, or galaxies without hitting a single atom. To understand how unlikely it is for a neutrino to hit something, imagine a wall made of solid lead that is 1 light-year thick. That's almost 10 trillion kilometers. Even if billions of neutrinos entered that wall, about half of them would come out the other side without touching anything. That is how ghostly these particles are. The Earth, compared to that, is nothing to them. It is as if it were transparent. So, the neutrinos from the Sun travel through space, pass through the atmosphere, move through your body, and exit out the other side as though nothing were in their way. Since neutrinos are so hard to detect, you might wonder how scientists even know they exist. The answer is that they have built special detectors designed to catch the rare moments when a neutrino does interact with matter. These detectors are usually very large and are often placed deep underground to protect them from other kinds of radiation that could interfere. One famous example is the Super Kamiokande detector in Japan. It is a giant tank filled with 50,000 tons of pure water, surrounded by light sensors. When a neutrino hits a water molecule, it can create a tiny flash of blue light called Cherenkov radiation, and the sensors can record that flash. Another detector, called Ice Cube, is buried deep in the ice of Antarctica and uses the clear ice to detect similar flashes of light. Even with these huge and sensitive machines, scientists only detect a few neutrino interactions each day, even though trillions of neutrinos are passing through them every second. So why do scientists care so much about neutrinos? The answer is that neutrinos can tell us a lot about how the universe works. Because they rarely interact with anything, they can travel great distances across space without being absorbed or deflected. That means they carry information from places we cannot normally see, like the cores of stars or the centers of exploding supernovae. By studying neutrinos, scientists can learn more about how stars produce energy, what happens during cosmic explosions, and even what the universe was like shortly after the Big Bang. Neutrinos might also help explain one of the greatest mysteries in physics: why there is more matter than antimatter in the universe. Neutrinos are sometimes called the ghost particles of the universe, and it is easy to see why. They are invisible, silent, and nearly impossible to catch. Yet they are everywhere. Right now, as you read this, billions of them are streaming through your body, through your chair, and through the Earth below you, continuing their journey through space. They are part of the hidden world of particles and forces that shape everything around us, even though we cannot see or feel them. Thinking about neutrinos reminds us how mysterious and full of wonder the universe really is. The space around us is not empty at all. It is alive with invisible activity, filled with energy and motion that we are only beginning to understand. Every second, you are being touched by the universe itself, through countless tiny messengers that carry the story of stars, explosions, and creation. Neutrinos are proof that the most powerful and fascinating parts of nature are not always visible. They show us that even the smallest, quietest things can connect us to the vast, incredible universe we live in.